Hello and welcome to Quadratics 1.4 Solving Equations. Okay, so in this lesson, hey, we're finally actually gonna solve for x. Yeah, I think this is the first time this quarter that we're actually gonna solve for x, and yeah, let's get started. Kind of happy. Okay, so we're gonna solve for x, so that basically is the same kind of skills that you guys did back when you were in Algebra 1, and probably a little bit in geometry as well, where you basically just want to make the x by itself. Okay, so when you look at problem A. Yeah, you're going to say, oh yeah, there's two things that are attached to the x that we need to get rid of. And we want to get rid of negative 11 and we want to get rid of the square. Okay, and I guess one of the things that I recommend to my students when they get rid of the negative 11 and the square, I just tell them to use this technique called reverse PEMDAS, where normally if it's regular PEMDAS, where it's order of operations, you do exponent, parentheses first, then exponents, then multiply, divide, then add, subtract. So if you had to compare exponents in negative 11, you would do exponents first because that's first in order of operations, and negative 11 last because that's after it, right? But when we're solving for x, I like to tell my kids to just do like reverse PEMDAS, where whatever we normally did last in order of operations, we're going to get rid of first. Yeah, and whatever we normally do first in order of operations, we're going to do that last. Yeah, so I call it reverse PEMDAS. Okay. So we're going to get rid of negative 11. Ooh, actually, let me actually write the problem so I can start manipulating it in this space that I have here. So I got x squared minus 11 equals 37. Okay, so I'm going to get rid of the negative 11. Yeah, so to counteract negative 11, we're going to add 11. And a common thing that a lot of kids do is, yeah, they do that first part correct. They put plus 11 on the left side. But then they forgot that for equations, whatever you do on one side, you have to do on the other. So we better add 11 on the other side as well. And trust me, these kind of mistakes happen. So just make sure you're careful. Okay. So on the left side of the equal sign, we have x squared because negative 11 and positive 11 cancel out. And on the right side of the equal sign, we have 48. Okay. So notice how the negative 11 is gone. So we can move on now to the square. Yeah. And getting rid of squares is just basically doing what is called a square root. So this is also something you should have learned in your other classes. It's not brand new. Yeah. So actually, there's something I need to do. I wrote that 48 a little bit too close to my equal sign. So I need to make a little bit more distance between them. And you'll find out why very soon. Yeah. But let me just make that distance before I start putting the square root symbols on both sides. Okay, so to get rid of a square, the square that's attached to the x squared, I'm going to square root both sides. Okay, and one thing you'll remember is whenever you square root, yeah, to get rid of the square that's attached to the x, you're going to always create a situation where you're going to have a plus and minus on this side of your equal sign, where the answer is going to eventually lie. Okay, so whenever you do that square root on both sides, make sure you put the plus or minus right next to the square root with on the opposite side of the letter that we're going to solve for. Okay, and if you can get into that habit, then you won't lose points because you're actually missing out on half of the answer. Yeah, because there's going to be a positive version of the answer and there's going to be a negative version of the answer. So you want to make sure you put the plus minus in that spot. Okay, so on the left side, square root of x squared is just going to be x. And on the right side, I'm gonna go old school when I teach you guys how to break up the square root 48. I think the examples in the packets, they do something a little different, which is fine. If you want to do it that technique, that's fine. Yeah, but this technique that I'm going to show you guys now is gonna seem more familiar because a lot of your Algebra 1 teachers probably taught it to you guys this way. So I'm gonna break apart the 48 using a technique called factor tree. Yeah, and factor tree is something that you probably saw in elementary school where you start breaking up 48 into smaller numbers and you keep on breaking them up until every single number is prime. Yeah, so obviously 48 is not prime, so we can break it up into a number of different things. So you can break it up into 2 and 24, 3 and 16, 4 and 12, 6 and 8. Yeah, so you can use a variety of numbers to break apart 48, and just make sure you stop when you have prime numbers at the ends of the branches. Okay, so 6 and 8, they're not prime because they still can be broken up into smaller pieces. So I believe 6 I can break up into 2 and 3. And those two are prime, so I'm going to stop at that point. And 8 I can break up into 2 and 4. So the 2 I'm going to stop breaking up because that's prime. The 4 I can go one more step. I can go 2 and 2. Okay, so I'm going to make sure I want to make sure I don't lose all the ends of the branches, because that's all the numbers I'm going to stick in the square root. Yeah, so I got how many 3's? 1, 2, 3, 4 3's, and a single 3. Yeah, and I'm going to put dots between them because that's how we actually connect all those numbers back together again to get the 48. So make sure you connect them with dots. Okay, and with a square root symbol, your teachers back in your previous math classes taught you guys that when you deal with square roots and all these numbers are broken up into its factors, you're going to look for numbers that match. And if they match, you can circle them. And circling signifies that they get to go outside of the square root symbol, yeah, and they don't have to stay inside anymore. So we're going to circle the numbers that match. So these two pairs of 2's, they match, and these two pairs of 2's, they match. And should I circle the 3? And this is where you say, no, I don't think I can because he's missing something. Do you know what he's missing? Yeah, he's missing a partner, right? He doesn't have any matching 3 that I can circle, right? The other numbers like 2 and 2, the two sets of 2's that I circled, they paired up, they matched up, so I get to put them outside. Yeah, because that's basically what a square root does. It's looking for things that match so that it can go outside the symbol, basically. Yeah, this is how you can think of it. Okay, so how many sets of 2's go outside? So here's the part that kids always mess up when they start making careless mistakes. They put too many 2's on the outside of the square root symbol. So I'm going to actually write this wrong on purpose. So don't write this on your paper just yet, because I'm going to write it wrong on purpose. They do this. Yeah, because they're thinking that, oh yeah, I circled 2 2's, so I'm going to put 2 2's on the outside. Okay, but the square root is gonna pull out the number that was circled. So it just wants the number that was circled. It doesn't want both numbers that was circled. It just wants to put on the outside the number that's inside that red circle, which is, in this case, let me erase the extra numbers that I don't need. And that's all it needs, right? The first 2 is from that first circled pair that I circled. The second 2 is from the second circled pair that I circled. Yeah. And the 3 didn't get circled, so it got left behind. So you just leave it inside the square root. Yeah. And in your last step, you just put together the 2 and the 2 that's connected by multiplication. And just make sure you connect the 2's with multiplication. Now, some kids they connect it with adding, and in this particular situation, if you added it or multiplied it, it gives you the same result anyway. But you're supposed to multiply these two numbers. Okay, so you're going to get plus or minus 4 root 3. Okay, and there you go. Okay, so let's look at B. All right. So let me change the ink color so that you guys don't get messed up as far as which one is which. Okay, so now we have how many things attached to that x that we want to get rid of. We want to get rid of the 3, get rid of the square, get rid of the positive 7. So reverse PEMDAS, yeah? So get rid of the add subtracts first. So let's write down the problem so I can start manipulating it by writing things underneath. Okay, so we're going to get rid of the add subtracts. So that means we're going to get rid of positive 7. So to get rid of positive 7, we're going to minus 7. Okay, and when I minus 7, we're going to get 3x squared equals 48. Okay, so now we have a choice between getting rid of squared or getting rid of multiplied by 3. So like I said, reverse PEMDAS. Yeah, so the exponent's going to be manipulated last. Yeah, so I'm going to get rid of the 3. So to get rid of the 3, you just ask yourself this question. What connects 3 and x squared together? Because whatever connects them together, I'm going to do the opposite to break that bond. Yeah, so since 3 and x squared are connected by multiplication, I break that bond by using division. So divide by 3, and don't forget, divide by 3 on both sides. That's a super important step that kids always forget to do. They divide the variable side, but they forget to divide the other side. Yeah. So left side we get x squared, and right side we get 16. Okay, and this time I didn't forget. I put a space between the equals and the 16 so that when I start writing my square roots, then I have room to put the plus minus. Okay, so we're going to get rid of the square, and in the previous problem, it's the exact same step. We're going to square root both sides. And like I said earlier, once we put square roots on both sides, because we're going to get rid of that square, we got to put that plus minus right by our eventual answer. Okay, so Left side's going to be x. Right side. Okay, so this is one of those things where it's called a perfect square, where it's the exact same number multiplied together that's going to produce a 16. So in this situation, yeah, you can factor tree if you want. But if you already know that there's two exact numbers that create 16 when they multiply together, you can just write out those two numbers. And in this case, it's 4 times 4. And because I'm looking for numbers that are going to be matching up and paired up, yeah, since the 4 and 4 match, I'm just going to circle it. And because they got circled, they're allowed to go outside. Okay, so I'm going to get x equals plus or minus 4. And that's my final answer for that. Okay? All right. Oh, I forgot to write the answers on these lines. Yeah, I always do that. Whenever it's, even in class lessons, I forget to write the answer on these lines. Yeah, so if it's quiz time or exam time, don't forget to put the answer on these lines as well, because um, sometimes kids, and me too, yeah, when I start doing work on paper, and you're going to see it on the board this year too, it's going to get messy. Things are going to be all over the place, yeah, and I don't want to play Where's Waldo with your answers, so try to remember to put the answer on these lines so that when I look for the answer, then I just got to know and look at one place, because that's where I know the answer is going to be, and if it's right, then I just make sure the work that you did verifies the answer, and if it's wrong, then I try to figure out where you went wrong. Okay? All right, next slide. Okay, so we're still solving for x. Yeah. So in problem C, we have two things that are attached to the x. It's multiplied by 16 and the square. So which one do I get rid of first? Reverse PEMDAS. So I get rid of the 16. So actually, let me write down the problem so I can start manipulating it. So 16x squared equals 49. So I'm going to break the bond that multiply by 16 has. And to break that bond, I'm going to divide by 16. Okay, so divide by 16 on both sides. And unfortunately for this one, yeah, 49 and 16, they don't divide. Yeah, they don't even have common numbers that you can divide by and simplify that fraction. So they're just going to stay 49 over 16. So don't turn it into an improper, don't turn it into a mixed number. Don't turn it into a decimal. Just leave it as that fraction. Okay, and let's get rid of the square. Ooh, did I leave enough space? Yes, I did. Okay. Okay, so we're going to get rid of the square, so we're going to square root both sides, and this is the third time this step is happening where I'm square rooting both sides. So, like I said once again, make sure that when you put that square root on both sides, you put plus or minus right next to the side that has the eventual answer. Okay? And then in this problem, you're going to notice, oh, wow, why does 49 and 16 inside of a square root look so familiar and seems so like there's something about these numbers that's special about them. Yeah. And in my class, hopefully you guys get it in your brain that you need to know your perfect squares at least to 10 times 10. Yeah. And each quarter that happens, so this is only the first quarter, and each quarter that eventually starts, you want to start bringing that number up 5 numbers. So in the second quarter, you want to know up to 15 times 15. Third quarter, you want to go at least up to 20 times 20. Yeah. Fourth quarter, if I'm feeling mean, that I make you guys go all the way to 25 times 25, but yeah, usually you guys actually do what I say, so I don't have to like threaten you guys and say, yeah, we're gonna do 25 times 25 when fourth quarter hits. So yeah, just make sure you know at least up to your 10 times 10s for the first quarter. Okay, and if you can do that, you'll realize that when you start breaking up 49, you're gonna know, oh yeah, 49 is 7 times 7. And 16, that's the number we just did in the previous problem, so that's gonna be 4 times 4. Okay, and I know 4s can be broken up a little bit smaller. I know that. I told you guys that the previous problem, but because we're just going to look for numbers that match, yeah, you can write a whole bunch of 2s if you want. But since you already see the 4s that match, you can just avoid that step if you want to. It's up to you. Okay, so I'm going to circle numbers that match, and they're allowed to go outside. Okay, so here's the tricky part that kids always mess up on. I'm going to actually write this answer wrong on purpose. So tell me why this is the wrong answer. Tell me why it's not 28. And kids are like thinking, that looks correct, because isn't 7 times 4 28? But I already told you guys this is wrong. Okay, so what did I misinterpret from the previous step that made me get this wrong? Yeah, well, if you notice, yeah, in the previous problems, yeah, in the first problem, I guess, when I circled the numbers and brought them outside, yeah, I looked at what connected them all together in the first place, and it was multiplication in that first problem. But what's connecting 7 to 4 is not multiplication in this problem. What's connecting 7 and 4 in this problem is not multiplication, but rather it's division, right? Because 7 is on the top, and that line signifies division. Yeah, so divide by 4 basically. So when I bring these two numbers, 7 and 4, outside, I need to make sure I maintain the exact same relationship they had when they were inside the square root. So if 7 was divided by 4, then when they jump outside the square root symbol, it still better be 7 divided by 4. Yeah, and if I can keep that connection there, then I won't make a careless mistake like a lot of kids do. Yeah, so please make sure when the 7 and the 4, you circle them, that means they go outside. Make sure you keep that connection the same. Or if they're connected by division on the inside, they're still connected by division on the outside. Okay, and if you can remember that, then you're in good shape. All right, so let's look at letter D. Okay. Okay, so we're going to solve for x squared. Solve for x rather. So there's a plus 5 and there's a square. So reverse PEMDAS again. So get rid of my add subtracts first. So let me actually write the problem so I can start manipulating it. So how do I get rid of a positive 5? And hopefully you say subtract 5 on both sides. Okay. And when I do that, my left side becomes x squared because the positive 5 and the negative 5 cancel. My right side becomes 40. Okay, and then getting rid of the square, that step has happened already 3 times in this lesson already, this video already, so you know it's going to happen, right? Square root both sides. And what do I write right outside this square root on the right side? Plus or minus, yeah? Whenever you square root both sides, yeah, you put a plus or minus right on the side, that is the answer. So then we're going to factor tree, and this one not as easy to factor tree in your head because it's actually not a perfect square. Okay, so we're going to actually factor tree on the side here. So we've got 40 at the top of the tree, and 40 we can write 5 and 8. Yeah, 5 we know is prime, it can't be broken up anymore. 8 we did that already in the past in the previous problem, that's 2 and 4, and eventually 4 is 2 and 2. Okay, so I'm going to rewrite my problem, this step. Yeah, so x equals plus or minus, and I'm going to write all the ends of the branches inside this square root symbol. So I have 1, 2, 3 2's and a 5. So 1, 2, 3 2's and a 5, all connected with multiplication. Okay, and then I'm going to circle numbers that match. And this time I have 3 2's that match. So do I circle all 3? No, because this is a square root. So square roots are looking for 2 numbers that match. So I know there's 3 numbers that match, but that's for a different problem altogether. So don't circle all 3 2's. Just circle 2 of them that match. So unfortunately, this other 2 that's outside this red circle didn't have anybody to match up with, but no big deal, right? You can be partners with the 5. Yeah, I mean, you can't circle it and bring it outside, but at least they can create a different number when they are put back together again. Okay, but the 2 that got circled in the meantime can go outside, so x equals plus or minus. 2 that got circled goes on the outside. The 2 and the 5 that's on the inside, they don't match up, they don't get circled, they don't get to go outside, so you just put them back together again like Humpty Dumpty, and you get 10. Okay, and there's your answer. Yeah. So don't forget to put your answer on this line, so when I start checking quizzes and tests and exams and all that kind of stuff in the future, this is where I look to see the answer. Okay? Alright, next slide. Okay, last problem for the day, I think. Okay, so we have a lot of stuff that's connected to my x. We have a square, we have a negative 4 that's being multiplied to the x, and we have a positive 6. So let's write down the problem so that I can start manipulating it and getting the x by itself. So I'm going to actually make a mistake on my first step after I write down the problem, because I want to make sure you guys understand this is a common mistake that kids make all the time, and I don't want you guys to fall for it. Okay? So we're going to get rid of our add subtracts. Yeah. So a lot of kids, they see this 6 and they go, yeah, I'm gonna add 6 on both sides to get rid of the 6. Why do you think a kid would add 6 on both sides? What is motivating them to add 6? Yeah. And the motivation here is they see the minus sign right next to the 6. So they think, oh yeah. 6 and 4, yeah, they're connected with negative, this minus sign. So to get rid of the 6, I gotta add it to break that bond. No, that's not how you break that bond, because you gotta say this, yeah. This is a positive 6, and the only way to get rid of a positive 6 is to subtract it. So I know I kind of make that connection where you want to break the bond and stuff like that, but don't always take it that literally, I guess you can say. Yeah, you want to make sure you can cancel it out. Yeah, so you're going to cancel out a positive 6 by doing negative 6 on both sides. Okay, so on the left side, the 6's go away, so we got negative 4 x squared equals, and negative 194 minus 6 is negative 200. Okay, all right, so how do I get rid of negative 4? And here's where a second mistake happens. When I see kids doing this next step, they put plus 4 on both sides. Yeah, and I know exactly why they put +4 on both sides, because they see a -4, so they're trying to get rid of the -4 by adding it. Okay, but that is not the connection that is connecting -4 with x squared. The connection between -4 and x squared is multiplication, so to break that bond, you got to divide. Okay, so you divide by -4, and you get x squared on the left side equals, so negative here cancels out, so it makes a positive altogether, and 200 divided by 4 is 50. Okay, and now we're home free because you've seen this step many times already. So to get rid of the square, we're going to square root and put a plus minus on the side that eventually has the answer. And then on the side here, you're going to break apart that 50 with factor tree. So you're going to put 50 on the top of the tree, and you're going to think of numbers that make 50. So let's see, I can do like 5 and 10. Yeah, I know you can do 2 and 25, but you can do whatever you want, right? Just make sure you break up everything into its smallest pieces. So when you reach the end of the branch, it's basically prime. So 5 is prime, so I don't break it up anymore. 10 is not prime, yeah? So I break it up into 2 and 5. And now it's prime. 2 and 5 are now prime. Okay? So left side I get x equals plus minus, and then I write all the numbers that 50 broke into. So 50 broke into 255. So 2, 5, 5. Okay, and then I'm going to circle numbers that match. So what matches inside this square root symbol? Because, like I said, whatever matches gets permission to go where? Yeah, so 5's match, so where do they get permission to go? And hopefully this is where you say they get to go outside. Yeah, they get to go outside and play, just like in elementary school time. Yeah, so you're going to get x equals 5, and, oh, plus minus, almost forgot about that. Plus minus 5, because they got circled, they got to go outside. 2 didn't get to go outside, so you just leave them in the square root symbol. And there's your final answer. Okay, so actually, let's write it on this line also, plus or minus 5 root 2. Okay, and I think the other 2 slides, I think the next one, I think that starts the homework assignment already. So you guys got 1, 2, 3, 4. 4 problems for homework. Yeah, it's in the packet, so just check there for the homework problems. And yeah, I'll see you later. Bye-bye.